Welcome. You have nothing to do right now, nowhere to be, nothing to figure out. Let your body sink a little deeper into wherever you are resting. Let your breathing slow, let your eyes grow heavy, and simply allow yourself to be carried gently through one of the quietest and most beautiful questions the human mind has ever held. The vast, peaceful silence of the cosmos and our small, tender place within it. Earth is the only planet we have ever confirmed to harbor life. Of all the worlds we have studied, all the moons and planets and distant rocky spheres we have observed, this one, our own, is the single place where life has been found without question. There is something deeply calming in that. Not lonely, but extraordinary. We are standing on the one confirmed island of life in all the cosmos we can see. Life on Earth began at least 3.7 billion years ago. That is a number so large, it dissolves quietly into wonder. Our planet was barely formed, still cooling, still settling, and yet already the first stirrings of life were beginning in its ancient waters. Billions of years of sunrises have passed since then. Billions of quiet nights, long before any eye existed to see them. The first life forms on Earth were single-celled microorganisms, so small they were invisible to any eye, drifting silently through warm ancient seas. They had no thoughts, no senses as we understand them, no awareness of the vast universe surrounding them. And yet, they were alive. They were the beginning of everything that would follow, every creature, every forest, every sleeping person on Earth tonight. Extremophiles survive in boiling hydrothermal vents on the ocean floor, deep beneath the surface of the sea, where no sunlight reaches and the pressure is immense, where water emerges superheated from cracks in the Earth's crust. Life has found a way to be. These tiny organisms thrive in conditions that would destroy most life. They remind us gently that life is more resilient and more inventive than we once imagined. Tardigrades can survive the vacuum of outer space for short periods. These tiny creatures, no larger than a fraction of a millimeter, are sometimes called water bears. Scientists have sent them beyond our atmosphere, exposed to the full harshness of space, and some have survived. They curl into a quiet, almost crystalline state and wait. They are among the most durable living things ever discovered on our planet. Life has been found thriving in the driest desert on Earth, the Atacama. Stretching across parts of South America, the Atacama receives almost no rainfall, sometimes going decades without a single drop. For a long time, scientists believed it was too dry for life, but they found microbes living in the soil, in tiny pockets of moisture, quietly persisting in one of the most inhospitable landscapes our world offers. Microbes exist 5 kilometers deep inside solid rock on Earth. Far beneath our feet, deeper than any mine, in the crushing darkness of the Earth's crust, life persists. These microbes live on chemical energy rather than sunlight, growing almost imperceptibly slowly, some of them perhaps thousands of years old. They have never seen the sky. They have never needed to. Life, it seems, will find almost any foothold it can. Earth's magnetic field shields life from deadly solar radiation. Invisible and vast, this field wraps around our planet like a quiet, protective embrace. It deflects streams of charged particles, constantly flowing outward from the sun, guiding them gently away from the surface. Without it, the atmosphere would slowly erode, and life would be exposed to radiation that would make the surface far more difficult to inhabit. It is one of Earth's silent gifts. Liquid water is considered the single most essential ingredient for life as we know it. Every living thing on Earth depends on it. Water is where the chemistry of life dissolves and flows and reacts. It carries nutrients, enables metabolism, and fills the space within every living cell. Scientists searching for life elsewhere in the universe begin, almost always, by asking one quiet question: is there liquid water here? That question will carry us far tonight. Let your body settle now, just a little more. Feel the weight of your limbs, soft and heavy against whatever holds you. There is nothing to solve tonight, nothing to remember, nothing to reach for. Let each breath come slowly, and let each breath go. You are safe and still, and gently held by the quiet of this moment. Simply rest. The habitable zone around a star is sometimes called the Goldilocks zone. Not too hot, not too cold, just right. It is the band of space where a planet orbiting its star might hold liquid water on its surface. The name comes from the old story of a girl and 3 bowls of porridge. And there is something quietly charming about that, something warm and familiar. Scientists use this simple idea as one of their first guides when searching the sky for worlds that might support life. Earth's axial tilt of 23.5 degrees quietly stabilizes our seasons and climate over very long timescales. That gentle lean, held steady through the ages, is part of why Earth experiences the slow, reliable rhythm of spring, summer, autumn, and winter. Without it, or with a wildly wobbling tilt, climates might swing into extremes too severe for complex life to settle into. That small, steady angle is one of the quiet reasons our world feels so livable. The Moon's gravitational pull helps stabilize Earth's axial tilt over time. Our large, faithful companion has been quietly doing this for billions of years, gently steadying our planet's lean the way a hand might steady a spinning top. Scientists believe that without the Moon, Earth's tilt could wander far more dramatically over millions of years, making climate far less predictable. The Moon, rising and setting so reliably above us, is doing something far deeper than simply lighting the night. Plate tectonics recycles carbon and helps regulate Earth's long-term temperature. Beneath our feet, enormous slabs of rock drift and shift with extraordinary slowness, and as they do, they draw carbon dioxide down into the Earth and release it again through volcanoes. This slow geological breathing acts like a thermostat, keeping our planet from drifting too far toward freezing or overheating across vast stretches of time. It is one of the deep, quiet processes that have kept Earth welcoming for so long. Photosynthesis by cyanobacteria oxygenated Earth's atmosphere 2.4 billion years ago. These tiny, ancient organisms drifted in shallow seas, quietly capturing sunlight and releasing oxygen as a byproduct. Over an almost incomprehensible stretch of time, they changed the very air of our world. Before them, the atmosphere held almost no free oxygen. After them, everything was different. It is remarkable to think that the breath you are drawing right now has its roots in the quiet work of microscopic life in an ancient ocean. The Great Oxidation Event made complex animal life eventually possible. When cyanobacteria flooded the atmosphere with oxygen, it was a transformation so vast it reshaped the entire planet. Many organisms at the time could not survive in this new oxygen-rich world. But for those that could, oxygen became fuel, an energy source powerful enough to eventually support larger, more complex bodies. That ancient shift, slow and quiet as it was, set the stage for everything that came after, including us. Complex multicellular life appeared on Earth roughly 600 million years ago. For billions of years, life had been small and simple. Single cells, thin mats of microbes, quiet chemistry in the sea. Then, gradually, cells began to cooperate. They began to specialize, to form structures, to build bodies. The first soft, many-celled creatures drifted in ancient oceans, simple and slow. But something had begun. The long, patient experiment of complexity had finally taken its first gentle steps. The Cambrian explosion produced most major animal body plans in under 25 million years. In geological terms, that is a very short time, a brief, extraordinary flourishing. Eyes appeared. Shells formed. Legs, fins, and mouths took shape. The seas filled with an astonishing variety of life. Scientists still find the speed of it remarkable. In the deep quiet of those ancient oceans, the templates for nearly every kind of animal alive today were being quietly written for the very first time. Humans have existed for only about 300,000 years of Earth's 4.5 billion year history. If you imagined all of Earth's history as a single calendar year, we would appear in the final hours of the very last day. Every civilization, every song, every story, every question we have ever asked, all of it fits into a whisper at the end of an almost endless story. And yet here we are, quietly looking up, wondering what else might be out there. That, too, is something worth holding gently tonight. Radio technology capable of reaching space has existed for only about 120 years. In the vast sweep of Earth's history, that is barely a breath, a thin sliver of time at the very end of everything. We have been broadcasting our presence into the cosmos for roughly 120 years, sending ripples of sound and signal outward into the dark. On a cosmic scale, we are just beginning to speak. Our voice is new, and the universe is very, very old. There is nothing you need to do right now, nowhere to be, nothing to figure out. Let your body grow a little heavier, a little softer. Let your breath slow, just a little. Each breath out carries the weight of the day a little further away. You are safe, you are still, and the night is long and gentle. Let your thoughts drift like clouds. No need to hold any of them. Just rest now, and let yourself float slowly, quietly, toward sleep. The first deliberate radio message sent to space was the Arecibo message, broadcast in 1974. Scientists gathered at the Great Arecibo Radio Telescope in Puerto Rico and aimed a precise, encoded signal toward the stars. It was a quiet act of extraordinary hope, a carefully arranged pattern of ones and zeros, carrying information about mathematics, chemistry, and the human form. A message in a bottle, placed not into the sea, but into the boundless dark between the stars. The Arecibo message was directed at a globular cluster called Messier 13, about 25,000 light-years away. A globular cluster is a tightly packed, ancient family of hundreds of thousands of stars, all orbiting slowly together. The message will travel for 25,000 years before it even arrives, and if anyone there ever receives it and replies, their answer will take another 25,000 years to return. It is the longest conversation humanity has ever attempted, patient, unhurried, and full of quiet faith. Earth constantly leaks radio and television signals into space as an unintentional beacon. Every broadcast ever made, every program, every transmission, every stray signal has been quietly escaping into the cosmos for over a century. By now, a sphere of radio noise more than 200 light-years wide surrounds our world, expanding outward at the speed of light. Without meaning to, we have been announcing ourselves. The universe, if anyone is listening, has already begun to receive us. The Pioneer plaques carry engraved diagrams describing humanity and Earth's location in the galaxy. Attached to the Pioneer 10 and Pioneer 11 spacecraft, these small gold-anodized aluminum plates were designed to be read by any intelligent being who might one day find them drifting through space. They show a man and a woman, the structure of a hydrogen atom, and a map pointing back to our sun, a quiet introduction etched in metal, sent gently into the unknown on our behalf. The Voyager Golden Record holds sounds and images representing life on Earth, mounted on both Voyager 1 and Voyager 2. This gold-plated copper disc carries greetings in 55 languages, music from around the world, the sounds of rain and wind and surf, and photographs of forests, children, and cities. It was assembled with great care, as if packing a small, precious gift for a stranger we will never meet. It is a portrait of everything we are, sent gently outward into the dark. Voyager 1 crossed into interstellar space in 2012, becoming the first human-made object ever to do so. After more than 35 years of travel, it passed beyond the influence of the sun's solar wind and entered the true space between the stars. Scientists confirmed the crossing by measuring changes in the particles surrounding the spacecraft. Something built by human hands had left the solar system. Quietly, without ceremony, a small machine from Earth entered the vast ocean of the galaxy. Voyager 1 is currently about 23 billion kilometers from the Sun. That distance is almost impossible to hold in the mind. Light itself, traveling at nearly 300,000 kilometers per second, takes more than 21 hours to make the journey from the Sun to Voyager 1 today. And still, it travels on, moving at about 61,000 kilometers per hour, growing more distant with every quiet moment. It is the farthest thing humanity has ever sent into the universe, and it carries a piece of all of us. The Moon is the closest celestial body to Earth, at an average distance of 384,400 kilometers. On a cosmic scale, it is our nearest neighbor, close enough that light makes the round trip in about 2.5 seconds. On a clear night, you can look up and see it hanging there, steady and familiar, its soft gray surface lit by reflected sunlight. Of all the objects in the universe, the Moon is the one that has watched over us the longest and the most gently. No confirmed signs of life have been found on the Moon. Every mission that has visited, from the Apollo landings to robotic orbiters, has returned with rock and dust, but nothing living. The Moon is silent in that particular way, ancient and still, holding no breath of biology within its gray plains, and yet it remains our most visited neighbor, a world we have walked upon, a place whose quiet surface still carries the footprints of 12 human beings. The Moon's surface is bombarded by micrometeorites and bathed in unfiltered solar radiation. Without an atmosphere to slow them or a magnetic field to deflect them, tiny particles from space rain down continuously onto the lunar surface, and the full force of the sun's ultraviolet and particle radiation falls unimpeded on every rock and grain of dust. It is a harsh and ancient environment, worn smooth by billions of years of this quiet bombardment. The Moon endures it all in perfect, patient stillness. Let your body settle a little deeper now. Feel the weight of your limbs, heavy and warm, sinking gently into the surface beneath you. There is nothing to hold on to, nothing to figure out, nothing that needs your attention tonight. Just let each breath come and go on its own, slow and easy. Your thoughts can drift like clouds across a dark sky. No need to follow them. You are safe and still and resting. Mars is the most studied planet beyond Earth for potential signs of life. For decades, orbiters, landers, and rovers have mapped its surface, sampled its soil, and analyzed its thin air. Something about Mars draws us: its reddish hue visible from Earth, its familiar seasons, its ancient valleys carved by forces we are still working to understand. Of all the worlds within reach of our instruments, Mars feels the most like a place that once might have known something like life. Mars once had liquid water flowing across its surface over 3 billion years ago. Scientists believe that in its early history, Mars was a warmer and wetter world, with rivers running across its plains and perhaps shallow seas pooling in its vast basins. Something changed. The atmosphere thinned, the planet cooled, and the water retreated underground or into ice. But for a long stretch of time, Mars held the conditions that on Earth gave rise to the first living things. Ancient riverbeds and lake basins have been mapped on the Martian surface. From orbit, instruments have traced the unmistakable shapes of valleys that water carved long ago, branching channels, delta fans where rivers once spread into standing water, and the smooth floors of basins that held lakes for perhaps millions of years. These features are preserved in the rock like a memory of a wetter world. Mars still carries the quiet record of all that water written in stone. The Curiosity rover detected organic molecules in Martian rock in 2018. Drilling into ancient mudstone in Gale Crater, Curiosity found complex carbon-based compounds preserved for billions of years. Organic molecules are not themselves signs of life. They can form through chemistry alone, but their presence tells us that the building blocks of biology were present on Mars long ago. Scientists received this finding with careful, measured excitement, knowing that each small discovery brings us one quiet step closer to understanding. The Perseverance rover is collecting rock samples for eventual return to Earth, moving slowly and deliberately across Jezero Crater, a place scientists believe was once a lake. Perseverance drills small cores of ancient rock and seals them in titanium tubes. These samples wait patiently on the Martian surface for a future mission to retrieve them and carry them home. When they arrive, they will be the oldest extraterrestrial material ever studied in Earth's laboratories, and they may carry answers we have been waiting a very long time to find. Mars has a very thin atmosphere composed mostly of carbon dioxide. The Martian air is less than 1% as dense as Earth's, too thin to breathe, too thin to hold much warmth, too thin to shield the surface from the sun's radiation. It is made up of about 95% carbon dioxide, with traces of nitrogen and argon. Standing on Mars, you would feel no wind worth mentioning, and the sky would be a pale butterscotch color at noon. It is a quiet, open, and very cold world. Seasonal methane spikes detected on Mars remain unexplained and scientifically debated. Instruments on the Curiosity rover have measured brief pulses of methane in the Martian air that rise and fall with the seasons. On Earth, most methane comes from living organisms, though it can also be produced by certain geological processes. Scientists are careful not to draw firm conclusions. The measurements are difficult to make, and the source is still not understood. For now, this small, quiet mystery drifts in the thin Martian air, patiently waiting for an answer. Recurring slope lineae on Mars were once thought to indicate briny liquid water seeping down hillsides. These dark, narrow streaks appear on steep Martian slopes during warmer seasons and fade when temperatures drop again. For a time, scientists hoped they might be trails left by salty water trickling through the soil. Later studies suggested the streaks are more likely caused by dry sand and dust sliding downhill. Still, the fact that scientists looked so carefully tells us how earnestly we search for any quiet sign of water. Venus has a surface temperature of 465 degrees Celsius, hostile to known life. That is hot enough to melt lead, hot enough to incinerate almost anything we know. The heat is not simply from the sun. It is trapped by a thick blanket of carbon dioxide in a runaway greenhouse effect that has persisted for billions of years. The surface is a dim, crushing, scorched world shrouded in dense clouds. It is a place that reminds us how delicately balanced the conditions for life truly are. Phosphine was tentatively detected in Venus's atmosphere in 2020, sparking quiet scientific debate. Phosphine is a gas that, on Earth, is mostly produced by living organisms or in certain industrial processes. A team of astronomers announced they had found traces of it floating in the Venusian clouds, and for a brief moment the scientific world held its breath. Subsequent studies raised questions about the detection, and the finding remains uncertain. It was a reminder that even a whisper of possibility is enough to turn our eyes gently toward the sky. Let yourself settle a little deeper now. There is nowhere you need to be, nothing you need to hold on to. Feel the weight of your body resting completely, every muscle softening, every breath arriving and leaving without effort. The vastness of space we have been drifting through is not something to figure out tonight. It is simply something to float alongside, gently and without hurry. Let your thoughts grow soft and slow, like clouds dissolving at the edge of a quiet sky. You are safe, you are still, and rest is already finding you. The upper cloud layers of Venus have temperatures and pressures surprisingly similar to Earth's surface. About 50 to 60 kilometers above the Venusian ground, the crushing heat and pressure ease into something far more familiar. Temperatures there hover between 0 and 50 degrees Celsius, and the atmospheric pressure is close to what we feel standing at sea level on Earth. It is one of the more quietly astonishing coincidences in our solar system that the most hellish planet hides a band of sky that feels in some ways almost like home. Some scientists propose that microbial life could theoretically float in Venus's cloud layer. If tiny organisms could survive the sulfuric acid droplets and the strange chemistry of those high clouds, they might drift through that tempered band of sky indefinitely. They would need to be extraordinarily resilient, far beyond anything we have found on Earth. It is a hypothesis held lightly, with great caution, and most scientists consider it a distant possibility rather than a likely one. But the idea itself is quietly beautiful, that life might sail through the clouds of another world. Europa, a moon of Jupiter, has a global liquid water ocean beneath its icy crust, beneath a shell of ice that may be tens of kilometers thick. Scientists believe a vast ocean of liquid water circles the entire moon. This ocean has likely existed for billions of years, kept hidden beneath its frozen roof, dark and still and deep. Europa is one of the most compelling places in the solar system when it comes to the possibility of life. The thought of an entire hidden ocean, quietly waiting in the dark, is one of the most wondrous things we know. Europa's ocean is kept liquid by tidal heating from Jupiter's gravity. Jupiter is so immensely massive that its gravitational pull stretches and squeezes Europa as the moon orbits, generating heat deep within the rock and ice. This gentle, continuous kneading keeps the water beneath the ice from freezing solid. Even though Europa is far from the warmth of the sun, it is a reminder that warmth does not have to come from a star. Gravity itself can cradle an ocean quietly and patiently across billions of years. Europa's ocean may contain twice as much liquid water as all of Earth's oceans combined. All the seas and bays and rivers and lakes on our entire planet, the Pacific, the Atlantic, the Arctic, every drop, may be less than half of what hides beneath Europa's ice. The scale of that hidden water is almost impossible to hold in the mind. And yet it is there, dark and immense, circling a small moon in the outer solar system. If life needs water, Europa offers it in extraordinary abundance. The Hubble Space Telescope observed water vapor plumes erupting from Europa's surface. Looking carefully at Europa, as it passed in front of Jupiter, Hubble detected what appeared to be jets of water vapor rising from the moon's south pole. If confirmed, these plumes would mean that material from Europa's hidden ocean is being vented directly into space, offering a way to sample that ocean without ever drilling through the ice. The idea of an ocean reaching up toward the stars, sending quiet signals outward into the dark, feels like something close to wonder. NASA's Europa Clipper mission launched in 2024 to study Europa's habitability. After years of careful planning and patient preparation, a spacecraft finally began its long journey toward that distant icy moon. Europa Clipper will make dozens of close passes, listening and measuring, building a portrait of what lies beneath the ice. It carries instruments designed to sense the ocean's chemistry, the thickness of the crust, the faint warmth rising from below. Somewhere out in the quiet dark, it is traveling still, steady, unhurried, carrying our curiosity gently forward. Enceladus, a moon of Saturn, shoots geysers of water, vapor, and ice into space. From the south pole of this small, bright moon, great plumes rise continuously upward, arcing silently into the darkness above. The jets are made of water vapor and tiny ice crystals, and they stream outward with a quiet, steady grace. Enceladus is only about 500 kilometers across, small enough to fit inside many countries, and yet it exhales into space like something breathing. The image of that small moon, venting its hidden warmth into the cold of the cosmos, is one of the most beautiful things our instruments have ever revealed. The Cassini spacecraft flew through Enceladus's plumes and detected hydrogen and organic molecules. Rather than simply observing from a distance, Cassini dipped directly into those rising jets, tasting the material that Enceladus was sending into space. Among the particles it sampled, scientists found hydrogen gas and complex carbon-based molecules, the building blocks that life, as we know it, tends to use. Cassini was not designed to search for life, and yet it stumbled into evidence of chemistry that feels deeply familiar. It passed through those plumes gently, gathered what it could, and carried the knowledge home across the years. Hydrogen in Enceladus's plumes suggests hydrothermal activity on its ocean floor. On Earth, deep beneath the sea, hydrothermal vents pour hot mineral, rich water into the cold ocean, and life gathers around them in great abundance. Scientists believe that the hydrogen rising through Enceladus's plumes may be produced by a similar process, hot water reacting with rock on the floor of that hidden moon ocean. If that is true, Enceladus may have warm, chemically rich environments in its depths, very much like the places on Earth where life first learned to thrive. The ocean floor of a distant moon, quietly churning in the dark, may not be so different from our own. Let yourself settle a little more deeply now. There is nothing you need to hold on to, nothing left to carry tonight. Let your shoulders soften and your hands grow heavy. Let your breath move slowly, in and out, easy and unhurried, like the slow drift of ice crystals falling through space. Each thought that rises can simply float past, gentle and weightless, dissolving into the quiet. You are safe, you are still, and the whole soft dark of the universe is resting alongside you. There is nowhere to go. Just this, just rest. Titan, Saturn's largest moon, has lakes of liquid methane and ethane on its surface. Titan is a world unlike almost anything else we know, a moon larger than the planet Mercury, wrapped in a thick orange haze with rivers and seas and rain, but made not of water, of methane. Near its poles, dark lakes of liquid methane lie still and flat beneath a hazy amber sky, their surfaces so calm they reflect the dim glow of distant Saturn. It is a world with weather and seasons and shorelines, and yet everything familiar has been quietly replaced by something strange and cold and beautiful. Titan is the only moon in the solar system with a dense atmosphere. Every other moon we know hangs bare against the vacuum of space, their surfaces open to radiation and the cold. But Titan is wrapped in a thick blanket of nitrogen and methane, with an atmospheric pressure at the surface about 1.5 times that of Earth's. Clouds form and drift. Rain falls. Wind shapes dunes of dark organic material across the lowlands. Titan does not merely have an atmosphere. It has weather and seasons and a sky. It is the only place beyond Earth where you could stand on a solid surface beneath an actual sky. Scientists speculate life, based on liquid methane chemistry, might theoretically exist on Titan. On Earth, life uses liquid water as its solvent, the medium in which chemistry happens. But on Titan, liquid methane fills that role, pooling in lakes and flowing in rivers across a frozen landscape. Some scientists have gently wondered whether a completely different kind of life might have found a way to use that methane, building cells and chemistry from entirely different ingredients. It would be life so unlike anything we know that we might not recognize it at first. The possibility is not a certainty, only a quiet, open question held with wonder. NASA's Dragonfly rotorcraft is planned to explore Titan's surface in the 2030s. Dragonfly is a drone, a rotorcraft designed to fly through Titan's thick atmosphere, hopping from place to place across the moon's surface, sampling the chemistry of different landscapes. Because Titan's air is dense and its gravity low, flight there is actually easier than on Mars. Dragonfly will visit dunes, plains, and perhaps the edges of ancient impact craters where water and organics may once have mixed. Somewhere in the coming years, a small machine will lift off from a launch pad on Earth and begin a long, quiet journey toward that amber world. Ganymede, Jupiter's largest moon, also harbors a subsurface saltwater ocean. Ganymede is the largest moon in the entire solar system, larger even than the planet Mercury, and deep beneath its icy and rocky surface, scientists believe a vast ocean of salt water is quietly waiting. The Hubble Space Telescope detected subtle changes in Ganymede's auroras that could only be explained by the presence of a conducting liquid layer beneath the surface. And so another hidden ocean joins the growing list: Europa, Enceladus, and now Ganymede, each one a dark and quiet sea, tucked away inside a frozen world, patient and still across the ages. Ceres, the largest asteroid, shows bright spots that may indicate subsurface briny water. Ceres drifts quietly through the asteroid belt between Mars and Jupiter, a small, rounded world of rock and ice. When the Dawn spacecraft arrived and sent back its first close images, scientists noticed something unexpected: brilliant white patches gleaming from the floors of craters, far brighter than the surrounding terrain. Those spots are now understood to be deposits of salt left behind as briny water slowly seeped upward from below and evaporated in the cold vacuum. Something beneath the surface of Ceres is still slowly, gently moving. Pluto's surface shows evidence of geological activity, possibly driven by a subsurface ocean. When the New Horizons spacecraft swept past Pluto in 2015, scientists expected a cold, dead world frozen in stillness for billions of years. Instead, they found a vast heart-shaped plain of smooth nitrogen ice, so young and unmarked by craters that it must still be actively renewing itself. Somewhere beneath that icy skin, heat may be slowly circulating, perhaps stirred by a hidden ocean of liquid water. Pluto, so far from the Sun, so small and quiet, may not be as still inside as it appears from the outside. The outer solar system contains dozens of icy moons that might host liquid water beneath their surfaces. Beyond Jupiter and Saturn, out toward the cold reaches of the solar system, there are dozens of moons, most of them small, most of them barely studied, each one a frozen shell wrapped around an unknown interior. Scientists believe that tidal heating and the slow decay of radioactive elements inside these bodies could keep water liquid far beneath their surfaces, even at such great distances from the Sun. The outer solar system, once thought to be an empty and lifeless cold, may be quietly scattered with hidden oceans, each one patient and dark and still. No biosignatures have yet been confirmed anywhere in our solar system beyond Earth. We have visited the Moon, sent rovers across Mars, flown spacecraft past every planet, and detected oceans hidden beneath the ice of distant moons. We have sampled atmospheres, analyzed rocks, and listened carefully for chemical signals that might hint at life. And yet, so far, every result has come back quiet. No confirmed trace of biology has been found anywhere beyond the surface of our own world. Earth remains, for now, the only place we know with certainty that life has taken hold, a single lit window in a very wide and very dark house. The nearest star system to Earth is Alpha Centauri, about 4.37 light-years away. 4.37 light-years sounds like a number, but try to hold its scale gently in your mind. Light travels at nearly 300,000 kilometers every second, and even at that speed, it takes more than 4 years to cross the distance between our Sun and our nearest stellar neighbors. If you could travel in a fast spacecraft at a tiny fraction of that speed, the journey would take tens of thousands of years. Alpha Centauri glows softly in the southern sky, a steady golden point of light, close by cosmic standards, and still breathtakingly far. There is nothing you need to do right now. Nowhere to be. No thought that needs following. Let your body grow a little heavier where it rests, and let your breathing slow, just slightly, on its own. If thoughts are still drifting through your mind, Simply watch them pass the way. You might watch clouds move slowly across a wide open sky. You do not need to hold them. You do not need to answer them. Just let them drift. Let the weight of the day soften and settle. You are safe and still, and resting gently at the edge of sleep. Alpha Centauri contains 3 stars: Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. What appears to the eye as a single golden point of light is actually a family of 3. Alpha Centauri A and B orbit each other in a slow, graceful dance, taking about 80 years to complete one full revolution. Proxima Centauri is a small, dim red dwarf that orbits much farther out, so distant from the other 2 that its connection to them is held only by the gentlest thread of gravity. 3 suns, bound together across the dark, each one warming its own small region of space, each one perhaps casting light on worlds we have not yet seen. Proxima Centauri B is an Earth-sized exoplanet orbiting in its star's habitable zone. In 2016, astronomers announced a remarkable discovery: a planet roughly the size of Earth orbiting Proxima Centauri, our closest stellar neighbor, at just the right distance for liquid water to potentially exist on its surface. Scientists named it Proxima Centauri B. It completes one full orbit every 11.2 Earth days, circling its small red sun in a tight, warm embrace. Whether it holds an atmosphere, whether liquid water truly rests on its surface, whether anything stirs there, all of that remains unknown. But it is there, quietly turning, just over 4 light-years away. Proxima Centauri frequently emits powerful flares that may strip away planetary atmospheres. Proxima Centauri is a small and ancient star, but it is not always quiet. It erupts regularly with intense bursts of ultraviolet and X-ray radiation, far more powerful relative to its size than anything our own sun produces. These flares wash over Proxima Centauri B in waves of energy that could, over time, slowly erode any atmosphere the planet might carry, stripping it away particle by particle into space. Whether the planet has a magnetic field strong enough to hold its air against those storms, scientists still do not know. It is a world of possibility shadowed by a gentle, ongoing uncertainty. The first confirmed exoplanet orbiting a sun-like star was 51 Pegasi b, discovered in 1995. For most of human history, we could only wonder whether other stars had planets of their own. Then, in 1995, astronomers Michel Mayor and Didier Queloz detected a world orbiting a star called 51 Pegasi, about 50 light-years away. It was a giant planet, something like Jupiter, but orbiting so close to its star that a full year there lasted only 4 days. That discovery opened a door that has never closed. The universe, it turned out, was full of planets, and we had only just begun to look. As of 2024, more than 5,500 exoplanets have been confirmed beyond our solar system. That number, gathered slowly over decades of careful observation, represents worlds that we know with certainty exist, planets orbiting distant suns, each one a real place turning in the dark. Some are vast and gaseous, larger than Jupiter. Some are small and rocky, not so different from the ground beneath your feet. Each confirmation required patience, precision, and years of quiet scientific work. 5,500 worlds, and the count continues to grow, softly and steadily, like stars appearing one by one after sunset. The Kepler Space Telescope discovered over 2,600 confirmed exoplanets during its mission. Launched in 2009 and operating for nearly a decade, Kepler was a quiet, tireless observer, a spacecraft that simply watched a single patch of sky and waited for the faintest flickers of light. It stared at more than 150,000 stars simultaneously, measuring their brightness with extraordinary care. Over time, those measurements revealed thousands of worlds crossing in front of their suns, each one a tiny shadow in the starlight. Kepler completed its mission in 2018, having transformed our understanding of how common planets truly are. Kepler data suggests there may be more planets than stars in the Milky Way. When astronomers analyzed the patterns in Kepler's observations, they arrived at a remarkable conclusion. On average, every star in our galaxy likely hosts at least one planet, and many stars host several. The Milky Way contains somewhere between 100 billion and 400 billion stars. If each one carries even a single world, the number of planets becomes almost too large to hold in the mind. A galaxy not of empty space, but of worlds. A quiet, immeasurable abundance drifting in the dark, most of them never yet seen by any eye. The transit method detects exoplanets by measuring tiny dips in starlight as a planet crosses its star. Imagine watching a distant candle flame and noticing, just barely, that it dims for a few moments before returning to its full glow. That is the essence of the transit method. As a planet passes between its star and our telescopes, it blocks a small fraction of the star's light, sometimes less than 1%. That tiny, regular dimming, repeated with each orbit, reveals the planet's presence, its size, and how long its year lasts. It is a method of extraordinary patience and precision, finding worlds by the shadows they cast across the light. The radial velocity method detects exoplanets by measuring the wobble they induce in their host star. A planet does not simply orbit its star, it also pulls on it, very gently, causing the star to trace a tiny circle of its own. As the star rocks toward us and away, its light shifts almost imperceptibly in color, bluer as it approaches, redder as it retreats. These minute shifts in the spectrum of starlight reveal the gravitational tug of an unseen world. It was this method that uncovered 51 Pegasi b, and it remains one of the most trusted tools in the search for distant planets. A star's quiet trembling, telling us something is there. TRAPPIST. One is a dim red dwarf star, 39 light-years from Earth. It is a small and ancient star, burning cool and rust-red, far less luminous than our own sun. From a distance it would be nearly invisible to the naked eye. 39 light-years away, close on the scale of the galaxy, yet still so far that light itself takes 39 years to make the journey. Astronomers discovered it using a small telescope in Chile called the Transiting Planets and Planetesimals Small Telescope, a quiet, modest instrument, watching a quiet, modest star and finding something extraordinary waiting there in the faint red glow. Let your body settle a little more deeply now. There is nowhere to be, nothing to hold on to. Let your shoulders soften. Let your hands rest open and still. With each slow breath, you are releasing the weight of the day, all of it drifting quietly away, like starlight dissolving into the dark. You do not need to follow every word. You can simply let the sounds wash over you, soft and unhurried, carrying you gently toward rest. The universe is wide and calm tonight, and you are held within it, safe and still and wonderfully small. TRAPPIST. One hosts 7 Earth-sized planets, 3 of which lie in the habitable zone. 7 worlds, all roughly the size of our own, orbiting a single small star in a compact and graceful arrangement. They move in resonance with one another, their orbital rhythms interlocked like a slow, celestial melody. 3 of those 7 sit at distances where liquid water could theoretically rest on their surfaces, not too hot, not too cold. Scientists name them TRAPPIST, 1EF, and G7 rocky worlds around one quiet star, 3 of them in the gentle band where life as we know it might find a way to begin. TRAPPIST-1e is considered one of the most potentially habitable known exoplanets. Of all 7 worlds in that quiet system, TRAPPIST-1e occupies a particularly promising position. It receives an amount of energy from its star that is comparable to what Earth receives from the Sun, and its size and density suggest it could be a rocky world with the potential to hold an atmosphere and liquid water. Scientists have studied it carefully, modeling its possible climates and surfaces with patient curiosity. Nothing has been confirmed, but among all the worlds we have found so far, TRAPPIST-1e stands quietly at the top of a very hopeful list. The James Webb Space Telescope is analyzing exoplanet atmospheres for biosignature gases, launched in 2021 and beginning science operations in 2022. The James Webb Space Telescope carries instruments of extraordinary sensitivity. When an exoplanet passes in front of its star, a tiny fraction of the starlight filters through the planet's atmosphere, and Webb can read the chemical fingerprints left behind, detecting the presence of water vapor, carbon dioxide, methane, and other molecules. Scientists are searching patiently for combinations of gases that life alone could produce and sustain. Each observation is a slow, careful reading of a distant sky, listening for chemistry that might whisper, "Something is there." Oxygen, methane, and water vapor together in an atmosphere would be a strong biosignature. On their own, each of these gases can arise through ordinary chemistry. But when all three appear together in an atmosphere, something remarkable is implied. Oxygen and methane react with each other and quickly destroy one another, so for both to persist at the same time, something must be continuously replenishing them. On Earth, that something is life. Scientists consider this chemical trio a fingerprint worth searching for, a quiet signature written in light, drifting across the vast distance between worlds. No confirmed biosignature has yet been detected in any exoplanet atmosphere. For all the careful observations, for all the patient hours spent reading starlight through distant skies, not one exoplanet atmosphere has yet yielded a confirmed sign of life. Scientists have found hints, intriguing readings that warranted closer study, but each one has so far dissolved under further scrutiny into more ordinary explanations. The search continues, unhurried and methodical. The absence of confirmation is not the same as absence. It simply means the universe has not yet answered, and we are still, gently, listening. Direct imaging of exoplanets remains extremely difficult because starlight overwhelms reflected planetary light. Imagine standing beside a lighthouse and trying to spot a single firefly circling it at a great distance. The blazing beam of the lighthouse swallows every faint flicker. This is the challenge astronomers face. A star outshines the reflected light of its orbiting planet by a factor of many billions. Sophisticated coronagraphs and space telescopes work to block the star's glare, revealing the faint glow beside it. A few exoplanets have been directly imaged, but each one represents an extraordinary technical achievement, hard-won and quietly celebrated. Even at the speed of light, a message to the nearest star takes over 4 years, one way. Light moves faster than anything in the universe, crossing the vast distance between Earth and the Moon in just over 1 second, reaching the Sun in about 8 minutes. And yet to travel to Proxima Centauri, the nearest star beyond our Sun, even light must travel for more than 4 years. A message sent today would not arrive until 4 years had quietly passed. A reply would take 4 more. Cosmic distances are not merely large, they are patient, unhurried, and humbling in the most peaceful way. The Milky Way galaxy contains an estimated 100 to 400 billion stars. 100 billion at the very least, perhaps 400 billion. The number is so large that no human mind can truly hold it, and yet each one of those stars is a sun, a radiant sphere of nuclear fire, many of them surrounded by their own family of worlds. If you counted 1 star per second without stopping, it would take more than 3,000 years to reach 100 billion. The Milky Way is not a collection. It is an ocean, vast and quiet and full of light. About 20% of Sun-like stars are estimated to have an Earth-sized planet in the habitable zone, 1 in 5. Among all the stars in the galaxy that resemble our own sun, stable, warm, long-lived, roughly 1 in every 5 is thought to host a world about the size of Earth, sitting at just the right distance for liquid water. That is not a rare exception. That is a pattern, a gentle regularity woven through the galaxy, like a recurring theme in a slow, quiet song. The universe does not seem to be stingy with the conditions for life. It offers them again and again across the dark. The Milky Way is estimated to contain at least 300 million potentially habitable worlds. 300 million, not distant galaxies beyond our reach, but worlds right here, within our own galaxy, planets of roughly the right size, orbiting roughly the right kind of star, at roughly the right distance for liquid water to exist. Scientists arrive at this number carefully, combining what is known about star populations, planet frequencies, and habitable zone boundaries. Whether any of those worlds actually harbor life, we do not yet know, but the sheer number of candidates is itself a kind of quiet comfort, a reminder that the conditions for life are not a fluke. Let your breath slow down a little more now. There is nothing you need to think about, nothing waiting for your attention. Just let your body grow heavy and still, sinking softly into wherever you are resting. Feel the warmth of the blanket, the quiet of the room, the gentle rise and fall of your own breathing. You do not need to hold on to any of these words. Let them drift past like slow clouds across a dark and peaceful sky. You are safe. You are still. Sleep is already close, moving toward you as gently as a tide coming in across a calm and moonlit shore. The galaxy is approximately 100,000 light-years in diameter, 100,000 light-years from one edge to the other. If you could travel at the speed of light without pause, you would need a full 100,000 years to cross from one side of the Milky Way to the other. Civilizations could rise and fall many times over in that crossing. The galaxy is not merely large, it is ancient and spacious in a way that makes distance itself feel like a kind of silence. And yet all of it, every star and planet and drifting cloud of gas, belongs to the same slow, turning whole. Our solar system sits about 26,000 light-years from the galactic center. We are not at the heart of the galaxy, nor at its outermost edge. We occupy a quieter middle ground, settled in one of the spiral arms, far enough from the dense and radiation-filled core to rest in relative calm. 26,000 light-years from the brilliant crowded center, our sun makes its slow orbit around the galaxy, completing one full circuit in roughly 225 million years. We are travelers, unhurried and steady, carried on a vast, slow wheel of stars, resting in a peaceful and unremarkable corner of something immeasurably grand. The galactic center is densely packed with stars and intense radiation, possibly hostile to life. At the heart of the Milky Way, stars crowd so close together that the sky would blaze with light in every direction. Massive bursts of radiation sweep outward from the central region, and the supermassive black hole at the core stirs the surrounding space with powerful energies. Scientists believe these conditions would make it very difficult for life, as we know it, to gain a foothold. It is a place of extraordinary beauty, but one that belongs more to spectacle than to stillness. Stars in the galactic habitable zone, a ring between 23,000 and 30,000 light-years out from the center, may favor life. This band of the galaxy is far enough from the dangerous radiation of the core, yet rich enough in heavy elements to allow rocky planets to form. Our own solar system sits comfortably within this ring, and scientists believe many other stars here share similar conditions. It is a gentle middle ground, not too wild, not too sparse, a quiet corridor of possibility winding through the turning galaxy. The oldest stars in the Milky Way are about 13.6 billion years old. These ancient suns were born when the universe itself was still very young, only a few 100 million years after the Big Bang. They have been burning quietly ever since, older than anything we can easily imagine. Some of them have witnessed the entire history of our galaxy unfold around them, the birth of billions of younger stars, the slow weaving of spiral arms, the long patient turning of cosmic time. They are still here, steady and ancient, glowing on. Rocky planets could not form until enough heavy elements were forged in earlier generations of stars. The first stars in the universe were made almost entirely of hydrogen and helium. It was only inside those early stars, through the tremendous pressure and heat of nuclear fusion, that heavier elements like carbon, iron, and silicon were created. When those stars eventually died and scattered their contents across space, they seeded the cosmos with the raw materials for solid worlds. Every rocky planet, including our own Earth, is built from the generous remnants of stars that lived and died long before our sun was born. The sun is a third-generation star built from the debris of previous stellar explosions. Our star did not emerge from pristine hydrogen alone. It formed from a cloud of gas and dust that had already been enriched by at least two earlier generations of stars living and dying before it. Every atom of iron in our blood, every grain of silicon in the earth beneath us, passed through the hearts of those earlier suns. We are not separate from the stars. We are made of them, assembled slowly from their long and generous lives, carried forward into this quiet corner of the galaxy. The search for extraterrestrial intelligence, known as SETI, began systematic radio searches in 1960. For the first time in history, human beings turned their instruments not toward the sky to simply observe, but to listen, to ask whether anyone else might be sending a signal. The idea was elegant and hopeful. If another civilization had developed radio technology, they might be broadcasting, just as we were. 1960 was a quiet beginning, a handful of scientists and a single radio telescope, but it marked the moment humanity formally began reaching out across the silence to ask whether anyone was there. Project Ozma in 1960 was the first SETI search, targeting two nearby sun-like stars. Astronomer Frank Drake pointed a radio telescope in Green Bank, West Virginia, toward two stars, Tau Ceti and Epsilon Eridani, both similar to our Sun and both relatively close, within about 12 light-years of Earth. For several months, the telescope listened quietly. No signal was found, but the act itself was remarkable, a careful, hopeful listening directed at worlds that might, in some quiet way, resemble our own. It was the first time a human being had truly listened for another civilization. The SETI Institute uses radio telescopes to scan millions of radio frequencies for artificial signals. The search is patient and methodical. Vast stretches of the radio spectrum swept carefully, frequency by frequency, looking for something that does not match the natural hum of the cosmos. Natural sources like pulsars and gas clouds produce their own radio emissions, but scientists look for patterns, regularities, or narrowband signals that nature alone would be unlikely to create. It is slow, quiet work, carried out across years and decades, a long and unhurried listening that continues even now as you rest. There is nothing you need to hold on to right now. Let your thoughts grow soft and loose, like mist dissolving over still water in the early morning. Feel the weight of your body settling, your limbs growing heavier and more relaxed with each slow breath. There is no signal to listen for, no question waiting to be answered. Just this quiet moment, this gentle dark, this easy rhythm of breathing in and breathing out. You have traveled far enough through the stars tonight. Let yourself drift now, slowly and peacefully, into the deep and restful quiet that is already waiting for you. The Allen Telescope Array in California is dedicated to SETI observations. Located in the high desert of Northern California, this collection of radio telescope dishes works together as a single listening instrument, scanning the sky for signs of artificial radio transmissions from distant civilizations. Named after technology philanthropist Paul Allen, the array represents one of the most sustained and purposeful efforts in the history of the search. The dishes stand quietly in the open landscape, patient and attentive, day after day and night after night, listening to the vast and mostly silent sky with calm, unhurried hope. No confirmed artificial signal from space has ever been received. Across more than 6 decades of careful, patient listening, every radio telescope pointed skyward has returned the same answer: silence or the natural murmur of stars and gas clouds. It is not a discouraging silence, but simply a quiet one, the kind that holds possibility within it. Scientists continue listening, knowing that absence of evidence is not the same as evidence of absence. The universe is vast, and our listening, though earnest, has only just begun. The WOW signal was a 72-second anomalous radio burst detected in 1977 at Ohio State University. Astronomer Jerry Eman was reviewing data from the Big Ear radio telescope when he noticed a strong, narrow-band signal that stood out dramatically from background noise. He circled it on the printout and wrote the word "wow" beside it in pen. The signal lasted just over a minute, then faded, leaving behind only a handwritten note and a quiet mystery that has never fully resolved itself. The WOW signal has never been detected again, and its origin remains unknown. In the decades since 1977, many telescopes have returned to that same patch of sky, listening carefully at the same frequency. Nothing matching that brief, bright signal has ever appeared again. Scientists have proposed several natural explanations: a passing comet, a quirk of interstellar hydrogen, but none has been fully confirmed. The signal remains a single, unresolved note in an otherwise quiet score, neither explained nor repeated, simply resting in the archive of the unknown. Fast radio bursts are intense, millisecond-long radio pulses from deep space with unknown origins. These brief, brilliant flashes of radio energy arrive from enormous distances, lasting only a fraction of a second before vanishing entirely. Some repeat, some do not. They carry enormous amounts of energy packed into an almost impossibly short moment, like a single bright blink from across the universe. Scientists have cataloged hundreds of them, and the search to understand their nature has become one of the most active and quietly fascinating areas of modern astronomy. Most fast radio bursts are now attributed to magnetars, highly magnetized neutron stars. A magnetar is the collapsed remnant of a massive star, compressed to a sphere only about 20 kilometers across, yet containing more mass than our Sun. Its magnetic field is so extraordinarily powerful that it dwarfs anything else in the known universe. When a magnetar's crust shifts or its magnetic field suddenly reorganizes, it can release a burst of energy so intense it travels billions of light years and still arrives as a detectable pulse. These are among the most energetic objects nature has ever produced. The Fermi paradox asks why the galaxy appears silent if habitable worlds are so numerous. If the Milky Way contains hundreds of millions of potentially habitable planets, and if life tends to arise wherever conditions allow, then over billions of years at least some civilization should have expanded, communicated, or left some detectable trace. Yet the sky remains quiet. No signals, no megastructures, no visitors. The paradox does not demand an alarming answer. It simply holds open a door of deep and unhurried wonder, inviting us to think carefully about what life, time, and the cosmos truly mean. Enrico Fermi reportedly asked, "Where is everybody?" during a 1950 lunch conversation. The story goes that Fermi, the brilliant Italian-American physicist, was having lunch with colleagues at Los Alamos when the conversation drifted toward the possibility of extraterrestrial life. Out of nowhere, He posed the question simply and directly, as if it had just occurred to him. His colleagues laughed, but the question lingered. It was not a fearful question. It was a curious one, the kind a thoughtful person asks while looking up at a clear sky and feeling the quiet enormity of what lies beyond. The Drake equation estimates the number of communicating civilizations in the galaxy. It multiplies together a series of factors: the rate of star formation, the fraction of stars with planets, the fraction of those planets that develop life, the fraction that develop intelligence, and so on, to arrive at an estimate of how many civilizations might currently be sending signals into space. The equation does not give a single certain answer. Instead, it organizes the question beautifully, laying out all the things we would need to know, like a gentle map of our own uncertainty. Frank Drake first wrote his equation in 1961 to organize a SETI conference agenda. The meeting, held at the National Radio Astronomy Observatory in Green Bank, West Virginia, brought together a small group of scientists to discuss the search for extraterrestrial intelligence for the very first time. Drake wrote the equation not as a precise calculation, but as a framework, a way to structure the conversation and identify what was known and what remained open. That quiet gathering of curious minds in the West Virginia hills marked the beginning of a scientific discipline built entirely on hope and patient listening. Let yourself settle now, gently and completely. Feel the surface beneath you, holding you with quiet steadiness as it always does. There is nothing to figure out, nothing to reach for. Let your breath move slowly on its own, in and out, like the long, easy rhythm of a tide. Each thought that drifts through can simply pass, like a distant light moving slowly across a deep sky. You are safe, you are still, and the whole universe is quietly turning without any effort from you at all. Let your eyes grow heavy. Let the questions dissolve. Let yourself drift, softly and without resistance, into the warm and waiting dark of sleep. The Drake equation's variables range from well-measured to deeply uncertain. Some of the factors, like the rate at which new stars form in the galaxy, are known with reasonable confidence from decades of careful observation. Others, like the fraction of planets that develop life or the fraction of life that eventually becomes intelligent, remain almost entirely unknown. The equation holds both kinds of knowledge side by side, the certain and the mysterious, without forcing them apart. It is a quiet reminder that science can hold open questions with great care and patience. Current estimates from the Drake equation range from less than 1 to millions of civilizations. That extraordinary spread from profound solitude to a galaxy teeming with minds reflects just how much we still have to learn. Some researchers, using cautious assumptions, conclude that we may be entirely alone in the Milky Way. Others, using more generous ones, imagine civilizations scattered across the spiral arms like distant campfires. Both possibilities are held gently, neither confirmed nor dismissed, resting quietly in the space between what we know and what we wonder. The Great Filter hypothesis suggests some step in the development of life is extraordinarily rare. The idea, proposed by economist Robin Hanson in 1998, asks why the universe appears so quiet if life should be common. Somewhere along the long path from simple chemistry to a civilization capable of reaching the stars, something must be stopping almost everything in its tracks. That barrier, whatever it is, acts like a filter, allowing almost nothing through. The hypothesis does not tell us where the filter sits. It simply notes quietly that something is holding the door nearly closed. If the Great Filter is behind us, life may be rare, but humanity is fortunate to exist. This possibility carries a strange, quiet comfort. It would mean that the hardest step, perhaps the leap from simple chemistry to living cells, or from single cells to complex organisms, has already been crossed. Humanity would represent something almost impossibly unlikely, a thread of awareness that found its way through a needle's eye so narrow that almost nothing else made it. There is something deeply humbling and gently beautiful about that thought, like finding yourself standing in a sunlit clearing after a long and difficult path. If the great filter is ahead of us, advanced civilizations may routinely destroy themselves. This possibility is the more sobering of the two, though it is held here not with fear, but with quiet reflection. It would suggest that the rare and difficult thing is not becoming intelligent, but surviving long enough to matter. That civilizations rise, reach outward, and then fall silent, not because the universe stops them, but because something within them does. It is a thought worth sitting with gently, not as a warning, but as a soft reminder of how precious and fragile the present moment always is. Nuclear war, climate collapse, and artificial intelligence are proposed future great filter candidates. Scientists and philosophers who think carefully about civilizational risk have identified these as the kinds of challenges that could, in principle, end a technological species before it reaches the stars. Each represents a threshold, a moment where a civilization's own power outpaces its wisdom. These are not certainties, and they are not causes for alarm tonight. They are simply the names of doors that thoughtful people believe must be navigated with great care, like narrow passes through high mountains, requiring patience and steady footing. The zoo hypothesis suggests advanced civilizations deliberately avoid contact with younger ones. Proposed by John Ball in 1973, the idea imagines that older, wiser civilizations have agreed, perhaps long ago, to leave developing worlds alone, watching from a quiet distance the way a careful observer watches a rare creature in its natural habitat. Under this hypothesis, the silence of the cosmos would not mean emptiness. It would mean restraint, a kind of patient, respectful stillness chosen by those who know better than to interfere. There is something almost tender about that thought, like being watched over by something very old and very gentle. The dark forest theory proposes civilizations hide to avoid being destroyed by others. The idea, drawn from science fiction but taken seriously by some researchers, imagines the cosmos as a place where any civilization that reveals itself risks being eliminated by another that cannot afford to take chances. Under this theory, the silence of the sky would be the silence of many minds holding very still, each one aware of the others but trusting nothing. It is a darker thought, and yet even here, there is a kind of quiet, a universe full of careful, listening presences, each one waiting, each one still. The rare Earth hypothesis argues the precise conditions for complex life are extraordinarily unlikely. Proposed by Peter Ward and Joe Kirschvink, the hypothesis suggests that while simple microbial life might be widespread in the universe, the very specific combination of factors that allowed complex animals to evolve on Earth may be vanishingly rare. Not just a planet in a habitable zone, but the right kind of star, the right kind of galaxy, the right geological history, the right neighbors in space. Like a recipe with hundreds of ingredients that must each be exactly right, the odds grow small with every requirement added. A large moon, a gas giant shield like Jupiter, and plate tectonics may all be rare combinations. Earth's unusually large moon steadies the tilt of our axis, keeping seasons stable across millions of years. Jupiter's immense gravity deflects many comets and asteroids before they can reach the inner solar system. And plate tectonics quietly recycles carbon, regulating temperature across deep time. Each of these, scientists believe, may be uncommon around other stars. That Earth has all three together, and perhaps more gifts we have not yet fully recognized, makes this small blue world feel, in the gentlest possible way, quietly extraordinary. Let your body settle a little deeper now. Feel the weight of your limbs, the softness of wherever you are resting. There is nothing left to do tonight, nothing left to solve or carry. Let each breath come a little slower, a little more gently. Let your thoughts drift the way clouds drift, loosely without direction, without needing to arrive anywhere. You are safe, you are still, and the whole quiet universe is simply here with you. Jupiter's gravity deflects many comets and asteroids that might otherwise strike Earth. This vast planet, more than 1,000 times the volume of Earth, acts as a kind of silent guardian at the outer edge of the inner solar system. Its enormous gravitational pull bends the paths of wandering rocky bodies, drawing them away from the fragile inner worlds before they can cause harm. Scientists believe this shielding effect may have allowed life on Earth to develop with far fewer catastrophic interruptions. Jupiter has been watching over us, quietly and without intention, for 4.5 billion years. The Milky Way may have experienced a gamma-ray burst sterilization event in its distant past. Gamma-ray bursts are among the most energetic explosions in the known universe, capable of releasing more energy in a few seconds than the Sun will emit across its entire lifetime. Scientists believe that billions of years ago, when the galaxy was younger and more turbulent, such a burst may have swept through large regions of the Milky Way with enough radiation to extinguish any life that had begun to take hold. It is a humbling thought that the history of life in our galaxy may have been reset more than once, long before Earth even existed. Gamma-ray bursts from nearby supernovae could strip away a planet's ozone layer. If a massive star exploded within a few thousand light-years of a living world, the intense burst of radiation that followed could tear apart the delicate atmospheric shield that protects surface life from ultraviolet radiation. Scientists believe such an event might unfold slowly enough to be invisible at first, a gradual dimming of protection, a quiet unraveling. The ozone layer that wraps our own planet is only a few millimeters thick if compressed to sea level pressure. It is a very thin veil between life and the sky. Panspermia is the hypothesis that life or its precursors can travel between planets on meteorites. When an asteroid or comet strikes a planet with enough force, it can blast fragments of rock into space, and those fragments carrying microbes or organic molecules may eventually drift to another world and seed it with the beginnings of life. Scientists have found that some bacteria can survive the vacuum and radiation of space for extended periods, and that certain meteorites carry amino acids and other organic compounds. Under panspermia, life might not begin independently on each world. It might travel, slowly and patiently, like a seed carried on the wind. The observable universe contains an estimated 2 trillion galaxies. That number is almost impossible to hold in the mind. 2 trillion, each one a vast island of hundreds of billions of stars, each one spinning slowly through the dark over billions of years. The estimate was revised upward significantly in 2016, when scientists analyzed deep-field images and realized that many small, faint galaxies in the early universe had gone uncounted. The cosmos is not merely large. It is so full, so overflowing with structure and light and ancient history, that the word large no longer quite fits. It simply is immense and quiet and endlessly patient. Each galaxy contains hundreds of billions of stars, implying an almost incomprehensible number of worlds. Multiply 2 trillion galaxies by the hundreds of billions of stars within each one, and the resulting number of stars in the observable universe reaches something close to 10,000 billion, a figure so large it surpasses the number of grains of sand on every beach and desert on Earth. And around many of those stars, planets quietly orbit. Most of those planets will never be named or visited or even seen. They turn in their darkness, patient and unknown, each one a world complete in itself. The cosmic microwave background radiation is the oldest light in the universe, from 380,000 years after the Big Bang. Before that moment, the universe was so hot and dense that light could not travel freely. It was trapped in a glowing fog of plasma. When the universe cooled enough for atoms to form, light was suddenly free to move, and it has been traveling ever since. That ancient glow now reaches us from every direction at once, cooled by billions of years of expansion into a faint whisper of microwave radiation. It is the oldest thing we can observe, a soft, even warmth that fills all of space, a memory of the universe's earliest quiet moment. The universe is approximately 13.8 billion years old. That age was measured with remarkable precision using the cosmic microwave background and observations of the universe's expansion rate. 13.8 billion years of stars forming and dying, of galaxies colliding and merging, of planets cooling and oceans gathering, and, on at least one small world, of life slowly waking to ask questions about where it came from. All of that time, all of that depth, unfolding in a silence so vast it holds everything. We are very young within it, and yet here we are, aware of it, looking back. The first stars formed about 200 million years after the Big Bang and contained no heavy elements. Those earliest stars were made almost entirely of hydrogen and helium, the only elements that existed in the young universe. They were enormous, far more massive than the stars we see today, and they burned brilliantly and briefly before exploding as supernovae, forging the first heavier elements in their cores and scattering them into the surrounding gas. Carbon, oxygen, iron, none of it existed before those first great stars lived and died. Everything that came after, including every atom in every living thing, traces its origin to those ancient fires burning alone in the very first darkness. Carbon, the backbone of all known life, was first forged inside massive stars. Deep within the cores of enormous ancient suns, temperatures and pressures so extreme that atoms fused together, building heavier and heavier elements from lighter ones. Carbon was born in that slow nuclear fire, assembled from 3 helium nuclei in a process so precise it seems almost deliberate. When those stars eventually exhausted their fuel and exploded, they released their carbon into the surrounding darkness, seeding the cosmos with the very element that would one day form the molecules of every living thing. Let yourself grow still now. There is nothing left to hold on to. Nothing that needs your attention tonight. Feel the weight of your body settling gently, as if the earth itself is drawing you down into warmth and rest. Let each breath come a little slower, a little softer. Let your thoughts drift like embers rising from a quiet fire, each one floating upward, dimming, dissolving into the dark. You are safe. You are held. Let everything go. The universe had to age for billions of years before the chemistry of life became possible. In the very early universe, there was no carbon, no oxygen, no iron, none of the elements that living things are built from. It took generations of stars to forge those elements, scatter them, and allow new stars and planets to form from the enriched dust. Billions of years of stellar births and deaths had to pass before the raw ingredients for biology even existed. Life, it seems, could not have arrived any sooner. The universe needed time to prepare itself. Humanity is observing the cosmos at an early stage, and civilizations billions of years older could theoretically exist. Our own technological civilization is barely a century old in cosmic terms. If life arose elsewhere in the universe even a billion years before it arose here, those beings would have had an almost incomprehensible head start. What they might have learned, built, or become in that time lies entirely beyond our imagination. We are, in the great story of the cosmos, something like a very young child who has only just opened their eyes. A Type 3 civilization on the Kardashev scale would harness the energy of an entire galaxy. The Kardashev scale, proposed by Soviet astronomer Nikolai Kardashev in 1964, ranks civilizations by their energy use. A Type 1 civilization uses all the energy available on its planet. A Type 2 harnesses the full output of its star. A Type 3 goes further still, drawing on the combined energy of every star in its galaxy, hundreds of billions of suns working as one vast engine. We have not yet reached even Type 1. The scale places us in quiet perspective. No megastructure or Dyson sphere candidate has been confirmed around any star. Astronomers have looked. The idea of a Dyson sphere, a vast artificial shell built around a star to capture its energy, would produce a distinctive infrared signature, and researchers have scanned stellar catalogs searching for that telltale warmth. So far, nothing has been found that requires an artificial explanation. The stars we observe, in all their variety, appear to be doing exactly what stars do naturally. The silence holds, not with disappointment, but with a kind of open, patient stillness. Tabby's star showed unusual dimming patterns once speculated to be an alien megastructure, formerly known as KIC 8462852, and nicknamed Tabby's star after astronomer Tabitha Boyajian, who led its study. This star dimmed in ways that ordinary planetary transits could not easily explain. The dips were irregular, asymmetric, and sometimes dramatic. For a brief and quietly exciting time, one of the possibilities considered, carefully and with appropriate skepticism, was that some vast artificial structure might be passing in front of it. Tabby's star's dimming is now best explained by irregular dust clouds. Further observations across multiple wavelengths revealed that the dimming affected different colors of light in the precise way that fine dust particles would. Dust scatters and absorbs shorter wavelengths more than longer ones, and the data match that pattern clearly. The most likely explanation is an uneven swarm of dust and debris orbiting the star, perhaps the remnants of a broken-up comet or planetesimal. The natural universe, it turns out, is strange enough on its own to produce wonders that briefly looked like miracles. Oumuamua was the first interstellar object detected passing through our solar system in 2017. Spotted by the Pan-STARRS telescope in Hawaii, it was moving far too fast and on far too steep a trajectory to have originated within our solar system. It had come from somewhere else entirely, from interstellar space, and it was already on its way out again. Reddish, elongated, and tumbling slowly as it traveled. It was unlike anything astronomers had catalogued before. For the first time, we had watched a visitor from another star system pass quietly through our own. Oumuamua's unusual acceleration briefly sparked speculation about artificial origin before natural explanations emerged. As it departed the solar system, it accelerated slightly more than gravity alone could explain. For a short time, one hypothesis, put forward seriously though cautiously, was that it might be a thin artificial sail pushed by solar radiation. Further studies suggested more natural explanations, including outgassing of hydrogen from within its icy interior as it warmed near the sun, a process that could produce exactly the observed nudge. The cosmos offered a mystery, and then gently offered an answer. Borisov, the second interstellar object detected in 2019, appeared to be a chemically ordinary comet. Unlike its mysterious predecessor, Borisov arrived looking familiar, a small, icy body trailing a faint coma of gas and dust, its composition remarkably similar to comets born right here in our own solar system. It carried water ice, carbon monoxide, and simple organic molecules. Scientists found this deeply reassuring in its quiet way, the same building blocks, drifting through the same dark between the stars, arriving from somewhere unimaginably far away, and looking somehow like something we already knew. Light from the farthest galaxies has traveled 13.4 billion years to reach our telescopes. When that light began its journey, the universe was only a few 100 million years old, and the first galaxies were just beginning to gather themselves from clouds of ancient gas. That light has crossed an almost incomprehensible distance, threading through the dark between galaxy clusters, bending gently around massive objects, until at last it reached a mirror of polished glass and was caught. We are not just looking into space when we study those faint smudges. We are looking into the deep, quiet past of everything. Let your body settle now, just a little more. Feel the weight of your arms, your legs, your shoulders, all of it resting, all of it held. There is nothing to figure out, nothing to remember, nothing to carry. Let each breath come slowly, and let each breath go. The mind can soften like a sky at dusk, the last thoughts drifting apart like clouds. You are warm, you are safe, you are here, and that is enough. Let the darkness be gentle. Let yourself drift. The cosmic horizon limits what we can ever observe to a sphere about 46 billion light-years in radius. Because the universe has been expanding since the Big Bang, light from regions beyond that boundary can never reach us, not in any amount of time, not with any telescope ever built. It is not a wall or an edge in any physical sense. It is simply the limit of what light can carry to us across an expanding cosmos. Everything we have ever seen, every galaxy, every star, every faint smudge of ancient light, lives within that great quiet sphere. Beyond it, the universe continues. We simply cannot know how far. Within that horizon, the sheer number of stars makes it statistically difficult to believe Earth is unique. There are estimated to be more stars inside our observable universe than grains of sand on every beach and desert on Earth combined. Around a great many of those stars, planets orbit. Around a great many of those planets, some conditions for life may be met. The numbers are so vast, so quietly staggering, that the idea of Earth as the sole cradle of life becomes harder and harder to hold. Somewhere in that immensity, the same chemistry, the same warmth, the same patient time may have done what it did here. The question of whether we are alone may be the most profound unanswered question in all of science. We have traveled tonight from the familiar ground of Earth outward, through oceans and ice and distant moons, past neighboring stars and ancient galaxies, all the way to the edge of what light can carry to us. And through all of it, the silence has been vast, and the wonder has been real. We do not yet know the answer. But the asking itself is a kind of gift, a reminder that we are small and curious and alive in a universe so large and so full of quiet possibility. Rest now. Let the stars keep watch. You are part of something immeasurably beautiful, and tonight, that is more than enough. Good night.